Dear all, in this session, let us understand how to draw the signal flow graph when the block diagram is given. See, in the earlier session, we understood how to find the transfer function when the block diagram is given. So we found the transfer function for the given block diagram by using the rules of block diagram reduction technique. Suppose if it is asked you to find the transfer function using Mason's gain formula, then you have to draw the signal flow graph for the given block diagram. Now let us just understand in today's session how to draw the signal flow graph for the given block diagram. First, for the given block diagram, you have to identify the nodes, because when you want to write the signal flow graph, first step is you have to write the nodes. Node. A node is considered in the block diagram at every summing point and at every takeoff point. Two extra nodes need to be considered in addition to that. One node at the input and other node at the output. Now first let us see how many nodes I need to consider. So in this diagram, how many summing points are there? 1, 2, 3. Then I should consider a node at every takeoff point. Where is the takeoff point? This is the takeoff point. A takeoff point means it is like a tapping point where the signal is tapped to give the connection to some other block. This is a tapping point or a takeoff point. Similarly, at the output here, it's a tapping point. So taking a signal here. Now together, how many? 3 summing points, and we have 2 takeoff points. Total 5 nodes. That is named as node number 1, 2, 3, 4, 5. In addition to this, you need to consider 2 extra nodes, one at the input, other at the output. So first, to draw the signal flow graph, write 5 nodes. 1, 2, 3, 4, 5. Then write 2 extra nodes, one at the input, other at the output. Okay. Now draw the signal flow graph. From the input here, signal is coming to node 1. So from input, signal is coming to node 1. Correct? You see the arrow, forward arrow. Now this is just a line. So you know that gain on a line or a wire is 1. Hence write here 1. That is the gain of this branch. Then from node 1 to node 2, this is node 1. This is one summing point, this is other summing point now. So from node 1 to 2, you write here, make the connection. And again, this is a line, so write 1. That is the gain on a line or a wire is equal to 1. This is the branch gain between the branch 1 and 2. Then node 2 and 3 you should connect. And this signal is passing through G1. Connect node 2 and 3, signal is passing through G1, hence the gain on this line is 1, G1. Gain on a branch between 2 and 3 is G1. Similarly, make the connection from node 3 to 4. So 3 to 4. It is passing through G2, right? G2 here. That is the gain of this branch. Again, node 4 to 5, make the connection because arrow is forward here. Node to 4 and 5. What is the gain? G3, because it is passing through G3. Hence, gain of this branch is G3. Then 5 to output. 5 to output. This is the line just right here. Gain as 1. Then remaining connections. From node 5 to 3, it is connected now. Signal is going from node 5 to 3, passing through H2. Node 5 to 3, passing through H2. But it is entering with negative sign. Hence, it becomes minus H2. This is the gain of this branch. You can write the arrow here. Okay. Next. 4 to 2. Signal is going from 4 to 2, passing through H1 but it is entering with positive sign, hence it is plus H1 here. 4 to 2 make the connection. Gain is H1. Then again signal is flowing from 5 to 1 arrow. 5 to 1 you should connect. 5 to 1. What the gain? 1, because there is no gain mentioned here, but entering with negative sign, hence it must be minus 1. We can see the arrow here. You can write arrow here or here, no problem. So this is how to write the signal flow graph for the given block diagram. Now let us take another example. Draw the signal flow graph for the block diagram shown. Now you can see here, this is the block diagram given. How many summing points are there? 1, 2, 3 again here. Okay. Then there is a takeoff point. This is one takeoff point between A and B block. We are taking a tapping. No, this is one takeoff point. This is one takeoff point. Again, you are taking a tapping here. And this is the at the output. You have a takeoff point. You are taking a tapping. So you can count how many nodes are there. This is first summing point. First node, they could be first node. This is second node. This is third node. This is a tapping point, fourth node. Summing point, fifth node. Again, tapping point, sixth node. Totally, there are 6 nodes. In addition to this, extra nodes at the input and at the output. Total 8 nodes. You can see here 1, 2, 3, 4, 5, 6. The same namings are given here. Extra nodes X, Y. As usual, let us make the connection. From X2 first node, make the connection. X2 first node, make the connection. Gain is 1. Then from 1 to 2, make the connection. Then what the gain here? 1. Then 2 to 3, make the connection. 2 to 3. What the gain here? Passing through A. No, A is the gain of this branch. Then 3 to 4, make the connection. 3 to 4. What the gain here? B. 4 to 5, make the connection. 4 to 5. So gain on a line is 1, write 1 here. Again 5 to 6, make the connection. Gain is 1. 6 to output Y, make the connection. Gain is 1. And remaining connection from node 3 to 5, there is a connection. Signal is going from 3 to 5. So there is no gain mentioned here, hence you take a gain as 1. But it is entering with plus sign now. Here plus is there, hence it is just plus 1. Then node 4 to 2, passing through C, entering with negative sign, hence it is minus C here. Again, 6 to 1, there is a connection, entering with negative sign, hence it is minus 1. So this is how to draw the signal flow graph for the given block diagram. And one more thing you have to remember, suppose if 2 blocks are in series, between the block also you need to take extra node. Even though there is no tapping point here, takeoff point, if 2 blocks are in series, between the block also you take extra node. If you don't take extra node, then you have to simplify those 2 blocks and you have to take that as a branch gain. So usually in a signal flow graph, so when the blocks are in series, then also you take extra node between the blocks. Okay, I think all of you have followed how to draw the signal flow graph for the given block diagram. Once you get the signal flow graph, then using Mason's gain formula, you can determine the transfer function for the given signal flow graph.